Hello friend, myself Sanjeev Divedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this conceptual video session for subject Advanced Algorithm. In this particular video, we'll be talking about master method and few proving techniques. Master method you must have studied during your semester 4. It is a cookbook method. It is one of the easiest method to solve recurrence relation, correct? But the recurrence relation here must be of the form Tn is Atn by b plus f of n. Remember, in last video we talked about a recurrence relation of the form Tn by 3 plus T2n by 3. Such recurrence relation is difficult to solve using master method. So for solving such recurrence relation, we must make use of recursion tree, which we did actually. Now, why I'm saying cookbook method? Because it's ready-made method. You are provided with ready-made answers. You just have to map it. So if we have any recurrence relation of the form T of n is Atn by b plus f of n, we just have to, and f of n is asymptotically positive function. Here, here we have value of a positive and b positive. Okay, greater than 1 to be specific. Now what happen is in this case my sub problem every time gets divided, my problem every time get divided into sub problem of size n by b, well, like the way I said, a and b are positive constants. So we will have n by b we will have a sub problem, we will have a number of sub problem, each of size n by b. Try to understand, a problem of size n is getting divided into problem of size n by b, and there will be a sub problems, correct? And let f of n be the overhead. Let f of n be the overhead that will generate when we combine this. It's like when we are combining the solution with of these sub problems, it will generate some overhead, and let that overhead be represented by some asymptotically positive function f of n. Now let's see. So this is our master method. This is taken from Corben. This is taken from Corben, correct? It says if we have a recurrence relation of the form Tn is Atn by b plus f of n, what we need to find first, we need to find value of a, b, and we will see what is the function. Now once you got it, correct, you need to find value of n raised to log a by b. Okay. Now if we see that f of n is big of worst case of n raised to log a by b minus epsilon, it means that ideally speaking, if I simplify it, it is n raised to log a by b greater than f of n. So if n raised to log a by b is found greater than f of n, then we can write it as my complexity is n raised to log a by b. Remember, if n raised to log a by b is found greater than f of n, then we can represent the complexity as n raised to log a by b. If f of n is equal to n raised to log a by b, then my complexity will be n raised to log a by b log n, lgn. Remember this. And if f of n is n raised to log a by b plus something, it means that f of n is, it means the n raised to f of n is obviously less than n raised to log a by b. Okay. Now in such case, we need to prove this. In such case, we need to prove this. You must have seen in last sem also. We need to prove that there is some constant c which is less than 1. We will have this equation to be condition to be satisfied where a f of n by b will be less than c f of n. And if we can prove this particular condition, then we can say that my time complexity is f of n. Now this is in general. Let me take one example on it. Now suppose here the recurrence relation is 9t n by 3. So a is 9 here, b is 3 here, and f of n is linear function n. So first we will calculate n raised to log a by b. So it is n raised to log a is 9, b is 3. So can we write n raised to log 3 square? So it will be n square log 3 3, so that will be n square. So n raised to log a by b is n square, which is greater than f of n. So see, what we have is n raised to log a by b is greater than f of n. Then our first condition is satisfied. So answer will be big O of n raised to log a by b, and this is what we have. What is n raised to log a by b? N square. So my solution is t of n is big O of n square. It is nothing but big O of n raised to log a by b, and we just found n raised to log a by b is n square. So this is one of the examples. We can solve many such examples. Ideally, what we should understand that master method is a ready-made method, and but the only point is in this case we should have a number of subproblem each divided into part n by b, and then only we can apply this. Correct? Now let us see some proving techniques. Now what is proving? See, a mathematical proof is an irreferent event for a mathematical statements. Correct? And showing that the stated assumption logically guarantees the conclusion. So what we needed, if we are given a statement and we need to prove that. Okay? So we have three methods with us. It's contrapositive, proof by contrapositive, proof by contradiction, and proof by mathematical induction. Let us see one of each. Now, proof by contraposition. Now, contraposition says, see, if it is a statement, if P then Q. So, if P implies Q says, if P then Q, and contrapositive will be negation Q implies negation P. The contrapositive will be negation Q implies negation P, means if Q is not, then P is not. So proof by contraposition infers the statement if P then Q. By establishing a logical equivalent contrapositive statement, we need to establish a contrapositive statement that if not Q then not P. Now let me take an example. Suppose a statement is given. See, if given statement is for an integer x, if x square is even, then x is even. Now we need to solve this. We need to prove it using contrapositive. My statement is if x square is even, then x is even. Correct? So I'm going to prove it by contrapositive. Now, so this is P, this is Q. Correct? So let us negate a Q. So let us say x is not even. So Q says x is even, negation will be, let us say x is not even. Now if x is not even, x will be odd. Now if x is odd, then product of two odd number is odd. Correct? So x square is x into x. X is odd, the product of two odd number is odd. It means that x square is also odd. Means we prove that if x is not even, then x square is also not even. So if not Q, then not P. And if this is true, then our assumption, see, but what we have is x square is even. It means that our supposition that x is not even is false. So we have to assume that x is even. Now try to understand. Once again, P says x square is even, Q says x is even. Correct? We need to prove this using contrapositive. So let us take take negation of Q statement. So it says as x is even, we'll consider it is not even. So we'll say, okay, let it be odd. Now if it is odd, x is odd, the product of 2 will be odd. Okay, 3 square is 9. Okay, na? 9 9s are 81. So please understand, x square is also odd. But what we have is x square is even. So see, if x is not even, then x square is not even. So but x square is even given to us. See, given to us. So our assumption that x is not even is false. So x has to be even. This is proof by contraposition. Now we have proof by contradiction. Now what do you mean by proof by contradiction? It says that, see, it is in Latin phrase, it is known as reductio ad absurdum. It means that reduction to the absurd. See, what it says, if some statement is assumed true, a logical contradiction occurs, hence the statement can be false. So if a statement is true, we have to come to conclusion to some logical contradiction to the statement. Correct? And then we can say, okay, you have given the statement, it was true, but I logically prove that the contradict occurs, so the statement is false. Now let us see one example. The example says, okay, square root of 2 is irrational number. We need to prove it by contradiction. Now, Now we say, okay, the given statement is a rational number, so let me contradict it. Let us consider it as a rational number. Correct? So please be here, concentrate. Now, if it is a rational number, can we say if it is a rational number, then it can be represented in form a by b with no common factors? Correct? So the minimum, the lowest term, that's, see, a by b, when I say rational number, it is a number of the form a by b where b is non-zero, and a by b will not have any common factor. So this is very important. A by b will not have any common factor. Correct? And if this is true, can we say b, can we take b this side? So we'll have b into root of 2 will be a. Correct? It's simple now, b comes here. So it is right now like this, square root of 2 is a by b. So next step is root 2b will be a. Now take square on both the sides. So what we achieved is 2b square equals to a square. Correct? Now, if I say 2b square equals to a square, matlab the left hand expression is divisible by 2. Okay? So if left hand is divisible by 2, then right hand must also be divisible by 2 because they are equal. Correct? So if a square is divisible by 2, then it is even. If a square is even, it means that a is also even. Now if a is even, can we write it in form of multiple of 2? See, if a is even, we can always express it in multiple of 2. So a, let us say a is 2c. So what we have is 2b square equals to a square. But what is a? 2c, because if it is even, it can be written in multiple of 2. So what we'll have is 2b square is 2c the whole square, which is 4c square. So what we have is 2b square is 4c square. I hope this is okay. Okay, and let us divide by 2. So it was 2b square is 4c square. We divided by 2. What we got is b square is 2c square. Now b square is 2c square means right hand side is divisible by 2. So even left hand side be divisible by 2. So left hand side should be even. So b must be even. Now earlier we proved here a must be even. Here we proved b must be even. Now if a and b both are even, they will have common factor. Now if they have common factor, we contradict this, that they have no common factor. So we reach to a logical contradiction that they should not have any common factor. Means our assumption that square root of 2 was a rational number is false. Correct? So we can conclude that square root of 2 is a rational number. So this is proof by contradiction. The next is proof by mathematical induction. This is what we are aware of it. Now in mathematical induction, we will first prove it true to be a initial value considered 1. Then we will consider that it is true for some n value, and we will prove it is true for some n plus 1 value. So first is we will prove true for some initial value. Then we will prove it to be true for some, we'll assume it to be true for some value of n. And we will prove it true for some n plus 1. So if it is true for first and true for 2 consecutive n and n plus 1, then it must be true for all. Let us see this. So we are given a statement 2n minus 1 is odd. We have to prove that. So for n equal to 1, 2n minus 1 is 1, which is odd. So we prove that it is true for n equal to 1. Let us assume 2n minus 1 is odd is true for some n. So if this is odd, we have assumed, so 2n minus 1 is odd for some n, we have assumed. Now if this is odd, when we add 2 to it, even this must be odd. So if 3 is odd, you add 2 to it, 3 plus 2, 5, even 5 is odd. So we assume that 2n minus 1 is odd, we added 2, it should be odd. Now when we solve it, 2n minus 1 plus 2, we reach to this point. 2 of n plus 1 minus 1 is odd. Now if this is odd, we proved it to be true for n equal to n plus 1. It was true for n equal to 1. We assumed it true for n and we proved it is true for n plus 1. So with mathematical induction, we can prove that it is true for all n. So this was proving techniques. Thank you very much.